I'll be going for the first 30 minutes, and I think Dr. Rebecca will come in.
Right.
Okay. So
You
today
can
we
go
are
like 30 minutes, Bashir. I'm trying to connect with my laptop. It is taking long, but I'll get it from.
all right. So today we are going to look at dplyr, an introduction of dplyr and its functions. So first of all, what we learned over the past days, these are like the basic functions within the R system. You may find so many ways on how people do things because R has so many options. So, for example, if I want to know how many males in the data set, I can just use the length, the length command, and I know the length of unique IDs for males. Which the DF1 sex is male. I think we changed the column to gender, is it? Might be gender, I don't know. Let me check. It's now gender. So it will give me the same answer as 57. So people have different ways on how they do things in R, and there are so many methods. So what we've learned, these are the basics, and they are the easy ones. Now, instead of going this whole lines or this whole line of code, someone could just simplify it by creating a simple database like this and determine the length of it, or just doing a table. So yeah, so for such a line of code, we normally use it in longitudinal data where the data is repeated. So if data is repeated, you would want to use unique a lot because unique means not repeated or distinct. Yeah. So don't mind about this code. If you want it, you can save it for yourself. So dplyr helps us with data management. If you learn how to use dplyr, it will help you a lot with data management. Data management includes cleaning data, then putting it in the formats you want, whether you want to include other variables, you want to derive other variables. That's all data management to make it usable for analysis. So the biggest part of data analysis is actually data management. If you get out a clean data set ready for analysis, is the biggest part of data analysis. So yeah, this is why you need to know how to use a dplyr because it is the basic tool in data management. So there are few things that you will learn, a few methods in dplyr. So if you want to know, you want help for dplyr, you can just write a question mark and dplyr. Okay. So when you press question mark and dplyr, you'll see that on your far right, it will bring the help all the notes of the dplyr. So you would want to go and maybe look at its index and everything. So there is this link of Tidyverse. They also give you other links on where to find help with dplyr if you need something to do with dplyr. Dplyr is we cannot finish it in one day. Even in the YouTube video, it is though they are like 1 hour videos, I didn't finish it. You just learn. I'm also still adding on. So it is a huge package. So, but we need to know a few things like this function. It is called this operator is called the pipe operator. Then we have things like filter, select, mutate, summarize, group by, arrange, they rename, relocate, distinct. All these are dplyr functions. But the biggest thing that we want to see, we are going to look at the pipe operator. And also we have this one, it's very important. So the pipe operator, which is a percentage, it's represented as percentage greater than percentage. This helps you, like how you hear the word pipe, to connect different commands into into one line of code. So for example, you would want to select, to filter, then select and mutate, then summarize. You can just use this pipe operator and it will do that. Okay. Let's begin with the select function. Okay, I think today let's use the flight data. No, let's continue using our DF. So today, this will be your practice for the flights data. Maybe if Dr. Rebecca wants to use it. So today we are going to look at filter. I want us to look at things that we started with select. Okay, I think let's start with selecting. With select. So we started with selecting columns, and in this first example, we were selecting columns 1 to 3, and columns 1 to 3 were ID, age, and gender. So if we want to select that with our dplyr, we can say df1. We are going to select it from df, and df1 is coming from df, and we are going to select. So we use the pipe function. Whenever you use a pipe function, means you are using dplyr. So you have to first call the library. So if you have already Tidyverse, you can just use Tidyverse because dplyr is within Tidyverse. If you don't have it, then when you installed only dplyr, you can call dplyr. So from df, we are going to select. We are going to say, what are we selecting? We are selecting ID. We are selecting ID, age, and gender. So these are now the variables we want to select. So when I run this and I look at my df1, it will be the same as the other one we created. It has selected ID, age, and gender. So that's the select function. So for dplyr, you don't need to cram which rows, which column, where are they. you just write the names of the columns you want. You want to select, you select. What else do we want to see? How many males? Okay, this is summarize. So let's have a small look at how age is going to be mutate function. So we have learned how to use select. Now let's see how mutate function works. So let's first look at the histogram of age. So the histogram, you just write, this is the base command. There is also a command with ggplot, as you will see. So this is the base command for plotting a histogram. So dfh, and it plots for you the histogram of the frequency distribution of age. You see, we have bars from 30, then we have those 50. So if, for example, we want to categorize those who are from 0 to 30, I mean from 0 to 29, then from 30 to 49, and from 50 and above. So we can, this is a mutate function. So one, let's say we want to create age groups, 20, 0 to 19, 20 to, according to our histogram, yes, 20 to 39, and 20 to 39, 20 to 49, and 50 and above. And we want to name them this, or we can give them values. So the values will be 1, 2, 3. 1, 2, 3. You know how values are important in analysis. So yeah, first of all, we can use the mutate function to do all of this. So we can create a df2. Our df2 is going to come from df1. So, and this time we want to mutate. So mutate function means you want to create or to add something to a data set that has not been there. Or you want to create a new variable UI. So it's simple, you want to create a new variable within the data set. So we want to mutate. And what do we want to mutate? We want to create age groups. So we want to create age groups, and that age groups, you see how now we are going to use the equal sign. So here we are going to use two things. I'm going to introduce the mutate and the if-else statement. So you can use the case when, but let's not use case when. Let me introduce you the if-else statement. So we want to say if-else, age, let me see the spelling of our age in this capital letter. If-else age is less or equal to 19, comma, let's give it a 1, the value 1, comma, and if-else age is, we say 20, greater or equal to 20, and age is less or equal to 49, less or equal to 49, comma, let's give it a 2. So we can type the last, but since there are two things here, there might be missing variables within our data set. And I think I'll tell you how to determine the missingness. So there could be missing values in our data set. If there are no missing values in our data set, we could just say, because the last category is the last category, we could say, comma 3. 3 as the last category. If else, age is less or equal to 19, give it a 1. If it is between 20 and 49, give it a 2, and the rest, give them a 3. But we could have missingness, and you have to take care of the missingness. So if there are missingness, so we can go ahead and we say if else age is greater or equal to 50, give it a 3, and the rest give it a missing. Okay. I hope you have understood this part. And here is another thing in R. For every bracket you open, you have to close it. So when we open the mutate bracket, as you can see here, and it is being closed the last. The second bracket we opened is for age groups of if else, and it is being closed by this bracket. And the last, this closes this bracket, and this closes this bracket. So they can be on the same line. Doesn't mean that they are, but it depends on how you want to arrange your things. So let's first do this, and we see how it goes. I'll tell you two things after. So if we look at our DF2, we have created age groups. 58 goes in 3, and if we table age groups, we shall see that we have one category 1, 2, and 3. Only 4 people are less than 20. Those who are between 20 and 49 are 60, 62. Those above 50 are 39. So this is how to use the if-else statement. Let's first do that. Do I need to explain something? If you are lost, please tell me. Now we are on the real deal. If you don't get lost. If you are lost, tell me.
I beg your explanation again.
Okay. We want to create age group from 0 to 19, 20 to 20 to 49, and those are 50 and above. And we want to give them values 1 for those who are between 0 to 19, value of 2 who are those who are, in fact, 0 to 19, let me just say less than 19. Value of 2 for those who are between 20 and 49, and the value of 3, those who are 50 and above. So this is how we create age groups. Should have put DF, not DF1. Okay. This is how we do. We want to create a data set called DF2, and it is coming from DF, our main data set. And in that main data set, we want to create these age groups. If you want to create a new variable called age groups, we use the mutate function in dplyr. So what do we want to mutate? We want to mutate or add age groups, and these age groups are, that's the equal sign. If else age is less than 19, give it a 1. If else age is between 20 and 49, give it a 2. If else age is greater or equal to 50, give it a 3. Or else let it be missing. Any A means missing. So anything that is greater than is outside these 3, it has to be missing. So that's why we put this option of NA. Remember, the if-else statement, I think I need to write it here. The if-else statement, the if-else function or statement has the condition, the value if true, and the value if false. So if else age is greater than 9, I mean less than 19, that's the condition. What value do you give if this is true? The value you give is a 1. If the value is false, it is a 0. All, I don't know, missing 0. But in this case, we have 3 categories. If we were going to do only 2 categories, we would only need one if-else statement. You give the 2 value, and if the value is false. So the second one is an if-else, the second statement for this value, for this, if this is not true, then we go for the second statement. The second statement says if age is between 20 and 49, the value that is true is 2. If else the value is false, go to the third condition. The third condition is if age is greater than 50, then the value, if true, is 3. The value, if this is false, is NA, which is missing. If anyone is missing these categories, they have to be just missing. NA means missing. So you run that. Please practice that in the next 5 minutes. So who is the first to, who is going first? Yeah, in fact, Jacinto, go first.
I'm still trying to type mine and to
No, you type with us. Please project your screen. Where are you?
I'm here.
Okay. So we are using our DF1. Let me first see the DF1. I mean the database that our sample database. Where is it? First show
I
it.
think, where am I?
No, in your environment,
Okay.
from your environment. Where is it? Jacinto, you don't have it.
No.
Why? You go where
Okay.
we. Mhm. But do you have it in your folder, in your directory?
Okay. Okay. The database I've been practicing on has been FD2.
What is that? You didn't get the practice database I sent?
Not really.
Ah, now what are we going to do now? Mhm. Because that practice data set, we intend to use it on several things. Huh? What's the name of the data sets? So as Jacindo is getting the data set, let me look for the link and I paste. Latifa, you project your screen. Please download that data set I've sent in the chat. Mhm. Take us through what you're doing. You are mute. What do you want from those things? Okay. Please unmute and take us through. I say Red Cross online 206. Latif, are you able to talk? Is it me? Who's not hearing her?
No, Bashir, you're very clear.
Latifa, we can't hear you. And if we can't hear you, we can't know what you're doing.
Can you get me now?
Yeah. So take us through what you're doing, how you've learned it.
Can't get you.
Think Latifa is not able to talk.
Can you
hmm?
hear?
Okay.
Can you get me?
Yeah, please take us through what you're doing.
But before I take you through, my code isn't running.
No. When you take us through how you've understood it, we shall find out the problem together. So you take us line by line, how you understood it.
Okay. So first, what we want to do, we want to create age groups. And to do that, we use the mutate function. So we want to assign, so we're going to use the if else function. So the age groups, we have less than 19, we have 20 to 49, then 50 and above. And we're going to assign those age groups using values 1, 2, and 3. So we use the if else function to do that. And can you get me?
Yes. Let's go.
So we use the if else function. Then to do that, so we begin by, so here I used this to rename. Then how do I do this?
The first condition.
So I'm using data frame from DF. So I use the mutate function. So now, so I use the if else function to assign. So the first age is less than. So I have age groups less than 19. So if the value is true, we use 1.
We assign it a 1 because that's what we said we are going to do.
Yeah, we assign it
Sometimes it
using
can be 0, or some people want to start from a 0 if they want to do maybe a regression analysis. Yeah, so for this case, for us, we decided 1. Go to line number 2.
for line number 2. If it's if else, if the age is greater or equal to 20, we assign
Yes,
it a 2. But here we have greater or equal to 20 and less or equal to 49.
because we want age to be between 20 and 29 and 49. That's the class we want. That's why
Okay.
we use the AND. There's using AND or the all. But now we want age should be between 20 and
Okay.
less or equal to 49. So that's why we put a 2 there. Before day we said we are going to use a 2 for that age group. Mm-hmm.
Then
Then last,
lastly, ages above 50 and above, we assign them a 3. If not, then they are missing. If we don't see if we have data, is it? And those people are not appearing in all those age groups, then they are missing.
yes. Some people use NA as missing, others use 9 or 99. It depends on what you use. Sometimes people use 99 to mean missing. So you go to your line 206, there is the X there, the red X. So you know why there is a red X? Look at that line. Where do you think the problem is?
Is it
It has even highlighted where the
on a
problem is.
2? Is it on a 2?
Mm-hmm. What do you need to put? So you see, this is the if else statement is for this age group is continuous. So to show that it is continuous, we use commas. So there is a comma missing at the end of two.
Mhm.
Now the red will go. Do the tables and see if we get the same results. Okay. Who else? Jacindo, have you gotten the data?
I have downloaded and saved and imported in the ARA studio.
Mm-hmm. Okay, show us.
Is this one? DF0.
Mm-hmm. I didn't give it the complex name. It is okay. You can call it DF just.
And I need to edit from the studio.
Yeah, so import. But what have you done?
I've imported it and I'm trying to set it as my working directory.
But it is saying can't be opened. What have you done? Uh, refresh your folder and I see if the data set is there. But the data set is not there. You haven't put it there. You renamed it zero.
Okay, I had renamed it F
No, it's okay. It
DF
doesn't
node.
matter
Mm.
how what you renamed it to. Click on it and import again and we see.
This one.
Click on it, import.
They're
That
telling me
file
it's
is
invalid.
invalid. So what did you do? First, show
I
us how you copied it and you downloaded it and you put it there.
okay.
Because you can't even see a preview. You cancel this. Mhm. Close that.
So it's not the cursor is not actually here. Okay. Now at the where you had set it as I mean send me the link. I opened from the link.
I see you have it opened in Excel there. You close that.
Yeah, from here, what I did was I tried to save it as
Mhm. Put it in your folder where we are working from.
That was the file name I assigned.
Mm-hmm.
Maybe let me try to change it now to DF. Then I saved it.
You close this, which is open. Open R again. Run the library, read Excel.
This one.
Mm-hmm. Run the library, read Excel. Mm-hmm. Type the command there. df equals not equals. First, remove that entire thing. Remove that line 174. So type df, assign it to my friend. Just type df. We are importing the df. You type df.
Okay, I typed DF.
It's okay. You type df. Mhm.
Sorry.
No, like, oh my goodness. So first delete those up to df. Put assign. Right. Read Excel. Read. Type read. Underscore. That first one. No. Wait. No, wait. Okay, that one. No. The second one. No, the one down. The one down. XLSX. That one. Click. Quotes.
Good.
Yeah, write quotes. Then the name of the data set. The open quotes. They are called. They are called quotation marks. Yeah. So inside, write the name of the data set. How you named it. How did you name it? You named it df
DF.
dot xlx one dot sir. It is xlsx. Run that. Have you named this? Have you set this as your working directory? Run again. No, just run this importing command. That one. Okay, it is now there. So do the if else statement.
I'll need you to project from such that I see the codes.
Let's do them together. So we are creating df2 from df. From df. Mutate. We are mutating. Mutate. Press enter. We are creating age groups. Underscore. It doesn't read. I want to read space. Underscore age. Okay. Equals. If else.
Pardon?
If else. It is underscore, not dash. Open bracket. So what is the first condition? Age was
It was
less
it
than
was
19.
less than 19.
Not what? Use your. It is age less than 19. Age is capital letter. You see how it has brought it? Yes. Less than 9. Less all equal to 19.
Can I put the sign?
Yeah. That is okay. Less all equal to 19. Where have you gone? Less all equal to 19. Where's the equal sign? Less all equal to 19. If you say less than 19, it will take 18.
Do I put stroke or I put
Yeah, like that.
less?
At the end, if that is true, what are we giving it? Comma?
1.
Comma 1. Comma. If it is not true, let's go ahead and we say press enter if else. If else. Bracket. Age is between 20 and 49. So that means age is greater or equal to 20 and and is not the word, the ampersand. It is the ampersand and not a comma. Do you know how the ampersand looks like? Yes. And age is it less or equal to 49?
Is less or equal?
Because we want from 20 to 49, yes. So if that condition is true, what do we give?
2.
And if it's not true, we go to the next condition. Comma. Where's the comma? If else, age is greater than if age is greater than 49. What is the condition? I mean, what is the value.
3.
All else, if it's not true, what do we give?
Give NA.
We give NA, it is missing. It is NA, not N stroke A. Run that.
Give error.
Yeah, you didn't run
Alright.
dplyr. Oh,
The,
wait.
the
It is
last,
okay. No, it is okay. The thing is okay. The error is telling you it is not finding the function of pipe. That means you didn't run the library dplyr. So run the library dplyr. Then go back and run that code. Open your do table, age group, and we see.
I open which one?
Do table age group and we see the numbers you're getting. The small letters, sir. Age group is coming from DF2. So you have to put DF2 $ age group. Okay. Andrew, I'm about to go. I think Dr. Rebecca can start off from there. Dr. Rebecca, are you ready?
Hello, I'm ready.
Okay.
Can he can stop sharing his screen, then I share mine.
Oh, Andrew had not taken us through what he has done. Oh, okay. Andrew, do you have any problems?
No problem, sir.
Okay, then we can move forward. So yeah.
Yeah, so before Bashir, you take off.
I'm trying to share my screen.
Yeah, it's coming, Rebecca.
It is coming.
Yeah, it shows that it's coming.
Okay. Sorry, my network I think is a bit poor, but I think it is coming. Hope it works. It has stopped coming. Sorry, it is taking a bit long, but let me see. And I don't see it here in the participants. Let me first try to log it off. This count top of mine. As if it has hanged. Sorry, colleagues, it is taking long, but oh my God. I'm trying to change the room to see whether I can get the network. But I don't know whether it is. Are you seeing my screen? You put it back on this. Hello? Are you seeing my screen?
Not yet, madam.
Not yet.
Yeah, not yet. Rebecca, sorry, not yet. Yeah, it is dodging you.
And here it is telling me that the screen is being seen. Let me try again.
At least at first it was showing it, there was something coming.
Maybe I first stop sharing, then I share again and I see what happens.
Better.
And it is not on. Sorry, I'm trying to change the room to see whether I can get the network.
So once we get it from you, the whole plan is covered. No, these people have sanctions in their schools. They are very good.
I'm sorry, Abel, for my network, but I'm trying again.
Okay. No, we are patient. We are very patient.
Neighbors, please give me 10 more minutes as I figure out this thing.
Okay, okay. That's
Yeah.
okay.
Sorry. So my presentation is on
Good afternoon to you, Doctor.
visualization of data. And I want to thank Bashir for taking us through the first part. So in visualization, usually we are going to use the package ggplot2. So members, you can install packages ggplot2 and then call the library, call the package as library ggplot2. So what do we do with ggplot2? This one helps us to produce good graphics in R. And the data must be a data frame that contains all the data information to make a ggplot. In the data columns should be variables and the rows should be observations. So ggplot2 is a powerful and flexible R package implemented by this guy Wickham for producing elegant graphics. The GG in ggplot2 means grammar graphics in a graphic concept, and it describes plots by using a grammar. So what is ggplot2? It is a composition of data plus aesthetics and then geometry. So the whole plot is the plot that comes out. You must have data, you must have aesthetics, and then the geometries. Therefore, you should describe all these three items for you to have the plot. And data is data frame. Aesthetics is used to indicate X and Y variables in case you are using X and Y. It can be used to control the color, the size, or the shape of points, the height of bars, if it is a histogram. And then the geometry corresponds to the type of graphics. If you are going to say, I want a histogram, I want a bar plot, I want a line plot, I want a density plot, or a dot plot. So where you see geometry, that's what it describes. Aesthetics describes the variables, and the data is the data frame. So the functions we use to create these plots are so far here too. One is qplot, the other one is ggplot. So this qplot is a quick function which is easy to use for simple plots, and ggplot is a more flexible and robust function than a qplot for building a plot, but for it, it builds a plot piece by piece. Okay. So after creating plots, two other functions can be used. This last plot underscore returns the last plot to be modified. You can also use the ggSave to plot to save the plot as a PNG or a PDF in the same directory that you are working in. So the type of graphs that can come out that we can use to describe data, we can use a scatter plot, box plot, strip chart, histogram, density plot, bar plot, line plot, pie chart. There are very many of them. And this ggplot2 can help you to produce all these ones. So what I'm going to do now is to take you to the Arrow script so that we can see, you can see some of the, what exactly we can do. As Bashar introduced to us the different parts of the Arrow script. Let me see if it is not fine. Are you able to see my script?
Yes, Doctor.
Yes, Doctor.
Okay. somehow. It must give it a few minutes. Advantage. Okay, so colleagues, I don't know whether you've been able to install the ggplot package, but here, Abel, what do we do? Do I give them time to install or I go through?
You mean the ggplot?
Yes, the package.
Yeah, you run through. They have been installing some of them, but so shall give them chance to run them as well.
All right. So here we install the package first. I installed it. So we say install.package ggplot2. Then we say library ggplot2. And I also installed dplyr, which Bashar explained to you. And the data here that we are going to use is an inbuilt data in R, and it's called mtcars. So to call it from R, you just type data empty in brackets mtcars. Then you click there and you run it. Let me see whether it is being shown in the environment. I think let me first clear my environment, my console. Let me move everything. Okay. So when you click data mtcar, it is shown here in the console. I can run it again, yeah. And we can, if you want, you can look at the data by saying head car, mtcar. Let me see whether we are able to view the data. So it is here. Members, are you seeing it in the console? Hope you are seeing it.
Yes, Doctor,
Yes?
we are seeing it very well.
Okay. So when you run, it comes there. And if you want to view the whole data set, you can just type in capital V for view. And then in brackets, you can put there empty cars. And if you run that, you'll be able to see the whole data set. Let me see.
Excuse me.
My computer is a bit slow, but it should bring it. So here, let me see. It is supposed to bring it. Where? Anyway, let's continue for a while. So here you can assign this data and give it a new name. So here I said DF is empty card, and I just want a few columns from this data. So I want to use MPG, WT, and then CY. Only the first three. I need MPG, CLY, and WT. So here I can say DF is, it is coming now. But let me just go back. Anyway, it will show. It was bringing me the other command that I put for the whole data set. So as I was saying, I just want to use WTCYL. So you can just say C, and then you open the brackets and you put those columns that you need in quotes there. And then it can, when you say head DL, then it can show you. My computer is funny, very disorganized, but this is the data. It has brought it at last. Let me go back. I want to head DF. And so it has brought me MPG, WT, and CYL. Okay. And now I want to use this function qplot. So I have qplot. I have the variables here, MPG. I want to plot on X, MPG, and on Y, WT, using the data, MT cars, and the geometry. I just want you to plot using points. So as I said that in ggplot, the data, to get a plot, you need the aesthetics, and then you need the geometry, and you need the data. So for this case, data is empty cars. The geometry is, I just want to use points. And then the aesthetics is X and Y variables. So if you run this, we shall be able to have our plots. It is coming. So when you see this red button, you give it time. So here we are. We have our plot, and we say that we are going to use points. So you just have only points of the data, and you have your scatter diagram there. Then you may say that I want, in my plot, I want to get a smooth line, the line that will divide the data, will help that we want to know whether the data is linearly line is normally distributed or not normally distributed. That way we can have the line of best fit. So you just say smooth, and this one will give it to you. So when we write here, of course, we have said XY for athletics, data is empty curves. Then the geometry is, we want both the points and the line. So you run. Until this red goes off. Yes. So here we are. We have our smooth or line of best, the line that best fits the curve. Is the points in the scatter plot. So it is there. And then when we looked at the data, this CYL is a factor. So as you see here in the console, it's a factor of values 6, 4, and 8. They are just repeating. So here you have that function to specify that CYL is a factor. So we can say empty cars and CYL, we assign it as factor, and then we run that line so that it can sit as a factor. And next, I want to plot this data, but then I want to take the color to have the colors, the different colors for CYL, so that I can know that 6 points are these ones, the ones which represent 4 are these ones. So here I'm saying that to plot is MPG, the data is we are going to plot MPG and WT, but the data is empty cars. The color is, we are taking that one of CYL, and even the shapes are going to take the points for CYL. So when you run this, we shall have the points specified. Let's wait and see. Until the red button goes on. But it's because my computer, I think it's overloaded. It shouldn't take a lot of time. So it is done. We can check. And here are the plots. So, and in the key, this is CYL. So 4 is taking the red points, 6 is taking the green, and in 8 is taking the what? The blue. So you can see the distribution of CYL in the kata plot. Then you could want to generate some data which is described talking about females and males. This time you don't have a data set, but maybe you want to simulate. So we use the function set.seed, and we are using 1, 2, 3, 4. What is this? The use of this function? These numbers are random numbers. And for you to have these numbers reproduced, then you have to say set.seed. And I'm naming this data that I'm going to generate as W data. And this is a data frame, which is going to talk about sex. And sex is a factor. So we are going to replicate female and male, and we want each of them to, we want like 200 females and 200 males. So each is 200, and we want to look at, to generate their weights. And we are assuming the weight is normally distributed. So the number of females is 200, and the weight, let's take a weight in the range of 55, and then that one will begin for the male, 58. So we can run this. First of all, I need to run the function set.seed. And then I run my simulation. So I can now try to look at my data and see how it looks. So I don't only want the first 3, for example. So here it is. Down here, let me see. Can I scroll? Wow. So I'm not able to expand my screen, but at least you can see the data is here, sex and weight. And our random numbers, we have 53.7, whatever, 55. So that will be within the range from 55 years, ranging between 55 and then 58 for the male. And when we have now the data they are generated, we can do a lot of things. We can decide to say, let me plot sex on weight, sex in relation to weight, and my data is W data, and my geometry, I want a box plot. So when I run that, I should be able to get the box plot. Some few minutes, and we shall have the box plot. So with ggplot, as long as you specify the data, the variables, and what you want the geometry, which kind of plot do you want? Then you can always have it. So here is the box plot for female, and then this one's for me. Then we see that the distribution, of course, male, they seem to have a higher weight than the females, and you are able to report, to make a report of your data. We can decide to say that let us have a plot which has weights using this data, W data. The geometry, I want this time a density plot. And then you can also be able to label the x-axis as weight in kilograms and the y-axis as density. And then you put there even the title as density plot. So when I run that, this is it. We have the title, we have the axis labeled. The one for x-axis should be down there. So this is our density plot. Next, let us now try, we've been using the Q-plot. We can also use the ggplot. I want a ggplot. The data is empty card. The variables, aesthetics is X. On X, I want WT. On Y, I want MPG. Plus, there's a plus here. The geometry, I am going to use points. I can even specify the size of my points as in 1.5, and the shape is taking 18. So when I run that, let me see what I have. Here it is. So on the Y, I said MPG, on X is WT, and then I have these points. You can even decide to make them bigger by increasing the size value. The size value, yes. Then I can also have a ggplot using the same data. No, this time I want to use a W data. Aesthetics is the weight. I'm going to use weight. And then the geometry is the density plot. Let me see what comes out. Here you are. And instead of using the geometry, this code GEOM, you can also use start. And yeah, we want a density plot. When you run that, you can have a good plot. It shouldn't take long if you have a good computer. So as I was saying, the ggplot produces for you very good plots, depending on what data and yeah, so here we are. That is our density plot, but this time we have used the SAT function. So the ggplot, in ggplot terminology, the function GOM at point and GOM, GEOM density, those ones are called, they are the ones that we call layers in the ggplot terminology. We can now try to see, supposing I want to use different, maybe 2 layers to visualize my data. So here I'm going to use points, and I'm also going to use a line to join these points. So again, the formula is data, aesthetics, and then the geometry. So our data is empty cars. Our aesthetics, this is the short form. We just write aesthetics. I want X on X to be WT, and then Y MPG. Then there's a plus for me to specify what kind of geometry. So I'm going to use points and then the line. So when I'm writing my code, I say plus GEOM points, then plus. So the first layer is this, and the second layer is GOM line. So when I run that, I'll have this. I have the points, and I have these points being joined by a line. That is the beauty of the ggplot. I can also, it is also possible to use different data sets. Yes, we can use different data sets and different aesthetics in mapping, for mapping. Yeah. So what do we do? I want to use different data sets. So the first data set I'm going to use is empty cars, and the aesthetics is WT for Y, for X, and the MPG for Y, plus the geometry as points. So that is the first data set. Then I'm bringing in the second data set, but this time the data set that I'm bringing in, I just want the first points, the first maybe 6 points in empty cars. So the first data is the whole data, and then this one, just a portion of it. And I'm going to use color red for the line. And I'll be able to visualize what goes on. When I run that, then I have. So this is the second data set, and the first one is the all the points. So it is possible to plot 2 data sets especially when you are making a comparison. Yeah. And you can differentiate the 2 data sets maybe by using different geometries. It is possible, and then you have your plot. We can also, it is also possible to do simple calculations in the function. For example, you would have plotted your scatter plot and you realize that the data is not normally distributed, or the distance between the points is very big and you want to somehow reduce these distances by maybe taking the logarithms of the points. So you can do that. With the ggplot. So what I did here is like I'm going to use data, empty cars, athletics is X and Y, but then I want these X values, I want to take log to the base 2 of the X values, and I want to take log to the base 2 of the Y values. And what am I going to use? My geometry, I just want points. Yeah, so when I run that, then I have a scatter plot. This one. So by taking logarithms, you reduce on the dispersion of the and then again, you can test for normality and see that maybe how is the distribution. Or this new plot, you can also try to fit the line of best fit and see how these points are far from the line of best fit, or how near they are lying to the line of best fit before you make conclusions in your analysis. Okay, so that is that. We can use the function athletics at string for mapping data that has string objects. I had Mr. Bashar explaining what string that function means. So now I can say ggplot data, then athletics, I want to say string, and FC is WT, Y is MPG, and the geometry, I want points in red, and then I also want a more line. So when I run that, yes, I have my plot here. So I specify. So, and you see that when you look at the distribution of your points now are not very far from the line of the script. And that is it. When you have your plot, you can directly save your plots in the directory by using this function ggSave. So if you want it as a PDF, then you say my plot, I want it as a PDF. If you want it as a PNG, then you say my plot is PNG. But of course, you would have introduced my plot. You assign my plot is a ggplot. Data is MT cars. Athletics is WT and M whatever, plus the gene of the geometry I just need what? The points. And when you first run this, and then you come here and run my plots. And when you go to your directory, you will see the plot there. Yes. Hello, Abel?
Yes, Rebecca.
I think that's what I wanted to explain today.
Yeah, so what we do, we give them a chance to practice by them showing us what they have plotted, and then we can give them feedback. So you'll choose one by one, and then we see how their plots are looking like.
Mhm.
So maybe you can stop sharing your screen, and then we see
I
each
stopped
other.
sharing.
Yeah, then
But the
we see each
commands,
each of these people's screens, and then we once we are happy, we can
how can these commands?
Oh yeah, you hadn't shared this with them.
No,
So
maybe what
what you can do is just copy this entire code, the code you've been working with, and then share it in the chat, so they can copy it and paste it in their working.
I just okay.
Yeah, they can copy it and put it in
Right.
their working. Yeah, in their script window, and they can continue replicating it. Maybe if they have any questions to ask you, this would be the best time as well.
Maybe I copy as not saying that my message is too long. Let me just copy. But I remember a screen. Yes, I think members can see it. But I think it is. Hello.
Yes,
Yes, sir.
yes, doctor, we are
No,
getting
doctor.
there. Hello, I have a question for Dr. Rebecca. Hello. Hello, I have a question. Dr. Rebecca, are you online?
Yeah.